In this recording, we're going to look at transformations of exponential and logarithmic functions. So the initial function we're going to look at is f of x equals e to the x. Now the number e, if you're familiar with it, e is approximately 2.72. Okay, so just to start to get a handle on this number, what is this number? And it wants us to make a graph, so we're going to have to first make a table of values, and I'm not going to be able to do this mental math, but let's just sketch out a few x values and their corresponding y's. So let's go like from -2, -3, maybe -2, -1, 0, 1, 2. I think we're going to run out of space there based on the fact that this is pretty similar to 3, and if we do 3 to the third power, it would be 27, we'd be off our screen. So I think that's all we're going to be able to graph. So we go to our calculator, we can put these in our y equals, put e to the x into y equals, and then check out the y values. So these are the y values I came up with. Okay, so go ahead and graph those points, please, best you can. Okay, next it says to solve algebraically for the inverse of f of x. Alright, well, that sounds challenging. Let's see. So we know when we find an inverse, we switch an x and y, right? So let's do that. First off, we need to make this a y equals e to the x. That's not the inverse. That's simply the function written in y equals form. So our next stage is we're going to proceed to take the inverse of that by switching x and y. Let's label that. That's our inverse. Alright, and from there we're kind of stumped. We want to get the y by itself. So what we said is we're going to, when we're stuck in exponential form, let's put it in log form. So let's go. Okay, we need a log. Log needs a base. Base is e. The log is the exponent, so it's a y. And the x just falls into place as the argument of the log. So, well, log base e, there's a fancy way to write it. Natural log. That's all it is. Log with the base of e of x is natural log. I'm going to write it this way with the inverse of f of x. Let's make a graph. So basically we're going to switch the x and y for those points. Now for the new graph, this is going to be the x, and this is going to be the inverse of f of x column. All right, so I'm going to do my best, plot those points. You should do the same. Okay, we should always label the functions when we have two or more on the same function, on the same axis. So it says, describe the relationship. Well, what's our relationship? Was there any symmetry here? Are there any transformations involved? Draw in the line of symmetry if you're able. Yikes, I thought it was going to come out straight. Let's try one more time. This is what I want. That's the tool I want right there. Let's try this. That's better. That's our line right there. The line y equals x is the line of symmetry. Let's label it. It's the line of symmetry between any function and its inverse. Okay, so we say they're symmetric about the line y equals x. What point are these graphs going to intersect? If we have a function a to the x and reflect in the y-axis. Well, let's think about that. If I have a little graph, I have a function that's growth, it would look like that, right? And if I reflect it in the y-axis, it would look something like this. And I guess this could have been the original graph, right? It could have been decay. A could have been between 0 and 1. If I reflect the green one in the y-axis, it becomes the red. So I guess either way, I've got these two graphs, right? It's going to be one or the other. And the point of intersection is right here at 0, 1. Right? There's a couple ways we could say it. When you reflect a point 0, 1 is a point on the graph, And the only point that's not going to change is the point that is on the y-axis. Okay, so that y-intercept 0, 1 is not going to change. All right, that's going to be the point on the graph, because when you reflect a point that's on the line over the line, it stays on the line. All right. Now, this looks like a complicated little table, but really we're going to be putting some check marks in this column. We're going to put one check mark, and in this column we're going to put one check mark, etc. So, for example, we want to know if I want to create the graph y equals natural log of x, what do I need to do to y equals e to the x, or as it says here, the graph of e to the x is subjected to the following transformation. So choose one of these for each column. Try to do it without your calculator, just using your sense. Then play the recording when you're ready. Okay, so first off, natural log and e to the x. Well, we had that graph above, right? They're reflected across the line y equals x. Check. Negative e to the x. Well, any function that you negate, right, going back to parabolas, that reflects over the x-axis, right? Now I got two choices. Well, any function that you negate near the x, that reflects over the y-axis. And we saw that before. A negative exponent for e to the x means decay. So we go across the y-axis. And finally, any function where we add one outside of it adds one to the y values. So that's what this is saying there. We've got an x and a y where the x stays the same, y increases by 1. Check. Thanks for watching.